I presume you've watched and learned well from the previous videos on stoichiometry. If not, go back and do that. But for now, we're going to walk through several sample problems in full speed. I will step you through the first one. Here we go. How many copper atoms are there in 5 grams of copper wire? What are we being asked for? Atoms. Where is it starting us? What does it give us? Copper wire. Each of these you've got to know what it's asking and where it started. Why? Because I'm going to write what it's asking for on the left hand side of my equation. Notice this translates how many copper atoms. Okay, what does it give me? It gives me 5 grams of copper wire. I'm going to write that as my first item on the right side. Notice what I have here is a box. And I have a star. More about that later, so here we go. Now we're just ready for full speed. When are we done? When the unit on the right-hand side equals atoms of copper. So let's go forward with that. Where I'm at, I started out with grams. This does not equal that. So I know I need at least one more conversion factor. So what I'm going to do is convert grams to moles. And I'm going to do that using what? The atomic mass, the molar mass of copper from what? The periodic chart. Now notice at this point, I take the 63.55 and place it on the bottom. And I put the moles on the top. Am I done? Do I pick up my calculator now? Absolutely not. Why? Because my unit on the right still does not equal to the unit on the left. I know I need at least one more conversion factors. Who knows how many? So what do I know now? I'm going to convert moles. I need to get rid of moles. That no longer works. And I can convert that to atoms of copper. How do I know that? Because I'm familiar with Avogadro's number. And now you can see what do I have at this point. I have the unit on the right of atoms of copper. And what I'm looking for the box is atoms of copper. It is only at this point that I pick my calculator up and come up with the correct answer of 4.74 times 10 to the 23rd atoms of copper and 5 grams of copper wire.
Headlights.
What did we do? Here's your crash course. I just used what I call my box equals star approach. Box, what are you looking for? Copper of atoms. What does it give you? What does it start you with? What does it start you with? See, that's kind of cute, right? Start, star, okay. You may not be impressive, but it'll help. There we go. Box equals star. What's the simple formula here? Anyone should be able to do this. You set a box, you set an equal sign, and then you set that equal to the star. And you just keep adding conversion factors to the right until you get the answer that you're looking for. And what are your 3 conversion factors that you're going to use in stoichiometry? Molar mass. Where do you get that? From the periodic chart. What else are you going to use? Avogadro's number. Where do you get that? You've got it in your head. You've got it in your memory. You've got it on the cheat sheet. And what's the other one? The balanced chemical equation, the coefficients. Those are the only 3 things. Box equals star, and then start throwing one of these 3 things at it. Next problem, calculate the number of moles. I can already see what my box is going to be. It wants to know number of moles of oxygen are required to exactly with 4.3 moles of propane. There's my star. It's giving me this data. According to the balanced chemical equation. Okay, it tells us it's a balanced chemical equation, so we know that. So where does our box go? Number of moles of oxygen. Remember, below is where I put moles, and above is where I put grams or any other type of physical data. Macroscopic world up here, nanoscopic world down there. Okay, here we go. So what's given? 4.3 moles of propane. There's propane, so what am I going to put it? I'm going to put it right below propane because it's moles, 4.30. Well, this becomes a pretty simple problem. What do I have? Box equals star, so let's set that up. My box is how many moles of oxygen? My star is 4.3 moles of propane. And how many conversion factors am I going to need? I drew one arrow, so I need one conversion factor. I already know that. I'm going hunting for it. I'm going hunting for a conversion factor that will convert moles of this to moles of that. And what's that called? That is, we get that from the balanced chemical equation. That's the ratio of our coefficients. And what do we know here? We know that 1 mole of propane will give us 5 moles of oxygen. Going through the dimensional analysis, moles of propane goes away. What am I left with? Moles of oxygen. What am I looking for? Moles of oxygen. Boom, I'm there. Multiply it out. 21.5 moles of oxygen. 21.5 moles of oxygen is what you're going to get. Next problem. Calculate the grams of hydrogen that will react with 128 grams of oxygen according to the following equation. What does it want me to calculate? Grams of hydrogen. Grams is above, so that's what I'm going to calculate. That's my box. That's where I'm headed to. That will react with 128 grams of oxygen. So I'm going to write that 128 grams above the oxygen. So how do I get there? Well, I can see I've got to do several conversion factors. I have to go from grams of O2 to moles of O2. From moles of O2 to moles of H2, that's going to require another conversion factor. And from moles of H2 to grams of H2, and I will have arrived there. No problem. Let's just use our standard equation. What's it looking for? Box. Notice this equation says how many grams of H2. That's what I'm looking for. I'm putting that in math speak. And what am I starting with? Where's my star? 128 grams of O2. And boom, I just know I'm going to have 3 different conversion factors. And what are they? Well, I'm going to get them out. Oh, by the way, if we're going to map that, those of you who are like picture type of people, here we go. Where is your box? It's right over here at grams of H2. And where is your star? It's right here on grams of oxygen. And so you can actually see the flight path. 1, 2, 3. 1, 2, 3. So you know you're going to start and you're going to need 1, 2, 3 conversion factors to get you there. First conversion factor is going to be what? Grams of oxygen to moles of oxygen. Where do we get that? Anytime. You always get molar mass from the periodic chart. So digging into the periodic chart, it gives me this. I now go from grams. Where am I at now? Moles of O2, but I need to get all the way to grams of H2. So I know I need another conversion factor. So this time I need to go across this bridge from moles of one thing to moles of the other. What's the only way I know to do that? Looking at the balanced chemical equation. So I know from this balanced chemical equation that for every 1 mole of oxygen, I'm going to get 2 moles of hydrogen. Very good. So now where do we stand? Do we pick up our calculator now? Absolutely not, because moles of O2 have gone away, but I'm still at moles of H2, and that is not grams of H2. So I need another conversion factor. This time I need one that will get me across this bridge from moles of H2 to grams of H2. Oh, I know what that's called. Atomic weight, molar mass. Where do I get it? Same places I get that every time. From the periodic chart. When I look on my periodic chart, I will see that 1 mole of H2 weighs 2 grams. Remember, 1 mole of H weighs 1 gram, but 1 mole of H2 must weigh 2 grams. And now that I've set that up, let's do a count on our dimensions. See, moles of H2 crosses off, and that leaves me with grams of H2. But hey, that's what I'm looking for. And so I'll multiply that out and get... That's the wrong answer for those of you who looked ahead. 16 grams of H2. So what do we know? If I start out with 128 grams, I only need 16 grams of H2 to react with that. Here we go, the last problem. How many grams of magnesium oxide do I get starting with 42.2 grams of magnesium? 42.2 grams. Okay, I need to go grams of that, moles of that, moles of that, and then grams of that. Right. Okay, what am I looking for? How many grams of mag oxide do I get starting with 42.2 grams of magnesium? I can see I'm going to have to go from grams of magnesium to moles of magnesium. And then I can see that I'm going to have to go from moles of magnesium to moles of magnesium oxide, and then I can see that I'm going to have to go, my third conversion factor is going to be from moles of magnesium oxide to grams of magnesium oxide. Am I going to stop there? Yes, I am, because I can see my unit that I'm looking for is equal to the unit that I obtain, knowing that each of these other ones are going to exactly cross off. So let's just plug in the conversion factors and I'm done. Where do I get the ratio of grams to moles? Always. That's what a periodic chart does. The periodic chart tells me there's 43.1 grams of magnesium for every mole. Moles of something to moles of something else. Where do I get that? The balance chemical equation. So let's look at that. For every 2 moles of magnesium oxide, I'm going to have 2 moles of magnesium. So there we go. 2 moles of magnesium gives me 2 moles of mag oxide. Well, I can see later those are going to cancel, but that's a math thing. And finally, moles of mag oxide and grams of mag oxide. Well, there I'll have to look at the molar mass of mag oxide, so let's see what I can do there. Magnesium oxide is 1 mg and 1 O, and 1 mg is 24.3, and 1 oxygen is 16.0, so that's going to be 40.3. So I know there's 40.3 grams for every 1 mole. I now have a number, all my conversion factors. Put that in my calculator and wind up with 70.0 grams of mag oxide. And there's my answer. And there it is, cleaned up a bit. Congratulations. You've just completed a crash course in stoichiometry calculations.